Okay, so we're starting with arithmetic and geometric recursive sequences. Let me just show you, this can be super easy. 2, comma 4, comma, what do you think's coming next? Could be 6. What could it also be? 8. It depends if we're multiplying by 2 or if we were adding 2. That's exactly what the difference is between geometric and arithmetic is the way you say it. I know some of you are like, that's arithmetic. No, the way we say it for this unit is arithmetic. That's an arithmetic sequence. If you add something each time, it would be 6. If you instead were multiplying, you would not know until you hit the third term. Because all of a sudden, if you're multiplying by something, you realize, oh, then that number is different. You cannot tell from 2 terms what's happening. You can't tell if they added something or if they multiplied something, see? Until you get to the third term. That's why whenever you make a list, you should always make 3 terms in a sequence. Because the first 2 terms you could have added to get there, or you could have multiplied to get there, and you won't be able to tell. All right, so we always do 3 terms like this. All right, so that's a sequence of numbers. Well, of course, if I want to continue this, it would go 8 and 10. And if I wanted to put a dot, 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 you guys know that means it keeps going. Right? Okay. The 2, 4, 8, if I kept going a little bit, it might be like what? What would be next? 16 and then 32 and then dot, 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 because it could keep going like that, right? All right, well, there is a very fancy way to describe this called a recursive rule. Now, recursive means that it refers back to itself. And this is a really important part. Would you please write U sub n above the number 6 there? If you haven't made this list, make the list and write U sub n. Now, oftentimes people don't understand what I'm saying there. It's U, that's easy, sub as in subscript, n. So that is a subscript that is supposed to be smaller and lower. All right, so it's U sub n. Then the next one is U sub something else, and I get it if you think that it should be a different letter, but it refers to the one in front of it. So that would be U sub, take a guess. Good guesses, but no. If I said U sub n again, that doesn't make any sense. And if it minus 1, I get how you want to subtract 1, but we went to the right. It's not subtracting 1. Yes?
It would be like U sub n plus 1.
That is exactly it. Nice. Well, then what would the next one be? U sub n plus 2. Very good. Or if I went in this direction, it would be U sub n minus 1. Excellent. Now, this and this, you will write at least 25 times before the end of this unit. U sub n and U sub n minus 1 are referring to any randomly chosen term and the term in front of it. Do you get that? U sub n just means a randomly chosen term from a sequence. U sub, I don't know which one it is, I'll call it n. U sub n, and the one right before that would have to be U sub n minus 1. You with me so far? All right, so if I said you get U sub n by taking the term in front of it and adding 2, can you speak math? A random term is given by the term in front of it plus 2. Do you get that's kind of describing what we just did a second ago? You just add 2 to the number in front of it. And then if I said my first term, U sub 1, was 2, I just described the even numbers. Because I start with my first term was 2, and then I'm just going to keep adding 2. So it's 2, and then what's the next one? 4, and the next one? 6, and the next one? 8, and that's the even numbers, isn't it? This is a fancy way to describe the even numbers. Let's see how smart you are. Can you give me the fancy way to describe the odd numbers? It's not much different. Write the recursive rule for the odd numbers. Work with that kid next to you. Tweak what I have. It's very similar to this. What's the recursive rule for the odd numbers? It's so simple. Just talk to the kid next to you. See if you agree. Talk him into it.
What?
Would you agree the odd number starts with 1? Then wouldn't I need to say my first term is 1? And then u sub n is given by u sub n minus 1. That's going to always be there. When I say always, I mean always. You're always going to have that right there in your rule. Always. And then, if I want to go up and make it the odd numbers, do I want the next number to be 2? No. If I just plus 1, the next number will be 2. Plus 2. Because, think about it, I want to go from 1, and then what's the next number I want it to be? 3. So to have that, I have to add 2. There, look at the difference. Isn't it subtle? Aren't they almost identical? It's just that they go up by 2, but you start with 2, and you go up by 2s, you get the even numbers. If you start with 1 and you go up by 2s, now you got the odd numbers. All right. Now, let's just go to a much more simple situation. Everybody write this down. 1, and then I'm going to add 6, 7, add 6, 13, dot, dot, dot. Do you get, I started with 1, and then I just kept adding 6. Does that make sense so far?
Yeah.
Now, is that the arithmetic or the geometric kind? I haven't made it super clear, but the kind where you add is called arithmetic. So everybody write arith near this. A-R-I-T-H, good abbreviation for arithmetic. That's an arithmetic sequence. Can you write me the rule for it? Int, it starts with u sub 1. And I said it always would have something else in it.
You just write U1.
Yes, u sub 1. The 1 needs to be a subscript. See, u1 is different than u sub 1. u1 would be written like this. U sub 1 has the 1 lower down in the subscript position. So u sub 1 equals 1. It's the starting number. That's that number right there. So u sub 1 equals 1. What did I say would always come next? U sub n equals u sub n minus 1. That means you start with any random term and you use the term in front of it. And then, what was I adding each time?
6.
There you go. There's your rule. There's your recursive rule for it. That is a typical test question. Do you think you could have done that?
Yeah.
All right. Now, there's one more little thing that you'd have to add. But I'm not ready for it yet because I don't want to confuse anybody yet. I want to just switch to multiply now and I'll show you how easy it would have been. If I start with 5 and I times by 5, would you agree it'd be 5 and then 25 and then 125? Does that make sense so far? Okay, so then this is typically u sub 1. It's the first term. So I'd say u sub 1 equals 5. What did I say would always be next? U sub n minus 1. See, all of that's so easy. Then I bet you somebody could put it together.
I'm fine.
Yeah, that's it. Times 5. There, that's a geometric one. You getting this? I hope this is easy. So then I should be able to go the other way and just give you this rule, and you should be able to tell me what the first 3 terms of it are. Why the first 3? Because from the first 2 terms, you can't tell if the kid knows what they're doing yet. Because you could be adding to get it by accident. All right, so here's another one. U sub 1 equals 7. U sub n equals u sub n minus 1, parentheses 3. Now with that parentheses, does that to you feel like I'm multiplying by it or like I'm adding it? Multiplying is correct. So would you please figure out the first 3 terms of the sequence? First 2 aren't any good. It's the first 3. Now some people get confused like, does the 7 count? Yeah, the 7 is the first term. So Becca Rowan, what did you get?
7, 6, 21.
7, comma, 21, comma, and then you times by 3 and you got 63. You are correct. Does that make sense? Yes, and that's a good idea to say dot, dot, dot. You don't actually have to. I just asked for the first 3. That would be it. Okay. Any questions so far? All right, then of course we have to make it a little harder. So, Do you have to, when you're counting, start with 1? No. Like for instance, let's say I said the year currently is 2024. U sub 2024 could be my first term. And let's say it's how many students are at Minnetonka High School, which is about 3,400. These are true. This is true. It's not exactly that, but it's in that neighborhood. Do you get that this could give us the chance to talk about how many kids we might have next year if we're expecting growth? Now, do we expect growth? Yeah, actually, Minnetonka has grown just a little bit every single year for a long time. Mostly open enrollment, allowing kids to enroll into our district if they want to. And so, yeah, I would expect it would grow a little bit. Because they kind of can control that too. Now, in new districts where they just developed the farmland and all of a sudden a whole bunch of houses went up and a whole bunch of people move into your district, they can't control it. And all of a sudden holy crap, we have 500 more kids or whatever. Minnetonka, it's more settled. And so the new growth we get is usually because of open enrollment. So let's say we go for 1% growth. What did I say was always next? U sub n equals U sub n minus 1. Very good. And if I want 1% growth, should I multiply by 0.01? No, because that would make it shrink. Not divide it.
1.1.
There it is. And yes, 1 plus 0.01 would have been totally okay. Do you get, by multiplying by 1.01, I'm going to get 1% growth? Why 1.01? Well, first of all, why the 1? Because that just brings back our original 3,400. And then when you multiply by 1.01, it's going to grow by 1%. Does that make sense? All right. See how this all of a sudden is kind of like the others, but it's a little more real world because we have a year built in there. U sub 2024. So then when we go to the next one, it'll logically be U sub 2025, and that means next year. And then we might have 1% more kids. And so then what would that be? Would that actually be 34 more kids? So then it'd be 34. All right. Okay. So what if I go the other way? I'm just going to give you a sequence. And can you tell me the first 3 terms? Don't say anything. Just in your head. Do a little bit of math. I know there's a little bit of multiplying involved. Write down the first 3 terms. And then I'd like you to put either a G or an A, because it's either geometric or arithmetic. And then I want you to compare your answer with the kid next to you and see if they get this like you get this. Sorry, there.
Did you get this, Will?
Cell phone in the backpack? You're not using it, otherwise you're losing it. But you're not using it, so you're okay.
YouTube is the second. Yeah, you guys don't know that. No, actually, I didn't know that. It's the second term.
Don't be afraid to talk to that kid. You have to be okay with making a mistake every now and then. It's okay.
Yeah, I didn't know that.
Just talk to him. All right. Did you know that the first term was 8? Some people don't think that, but it's true. You just recopy the first number that they gave you. Then you multiply by 2 and you put 16. And then you multiply by 2 again and you put 32. Raise your hand if you had that one right.
Yeah.
Uh-oh. Something looks wrong. There's no hands up. What the heck?
It's 4, 8, 16.
Ah. All right. U sub 2 is 8. So what are the first 4 terms? You get why I could totally get why somebody would have done what I just did, but U sub 1 would usually go here, U sub 2 would usually go here, U sub 3 would usually go here, and so U sub 2 is 8. The other one must have been a 4, and this one must be 16, and then your 32 is actually the 4th term. Does that make sense to you? Now, what are the first 3 terms? I actually think that that is a trick question, and I would have accepted that as your first 3 terms Because if you use this argument that it had to start with 4, then you wouldn't really understand that there's actually a u sub 0 too. There can be a u sub 0 just as much as there's a u sub 1. So who's to decide where you start? This is actually considered the starting term. That u sub 2, that is the starting term. And therefore 8, 16, 32, there was nothing wrong with that answer. This is the starting term. If they had asked you what is u sub 1, it would not have been 8. U sub 1 is clearly not the same as u sub 2. If they'd asked you for u sub 1, then you'd had to throw the 4 in there. Okay, so how about this? I'm going to start with u sub 0 this time just to show you can. U sub 0 is like at time 0 in the experiment, it was 72 degrees. Do you get the idea in experiment? You start at time 0. You don't start at time 1. At time 1 means like 1 minute or 1 second later. Do you get if it's heating up? Then it might go like this. What does that mean in words? Yeah, it's increasing by 2 degrees. Good. So, then if I asked you for the first 3 terms, some of you would be like, well, 72 doesn't count. No, 72 is the first term. I know it's not u sub 1, but it's the first term. You get the difference there? This is defined as the first term. Whether it's u sub 2024, or whether it's u sub 1 or u sub 0, it's the first term. So what is our first term? 72. What's the next term? 74. And the next term? 76. It's just going up by 2 degrees, period. All right. Now you're ready for one more thing that you're mostly just going to ignore, but it's important to have a domain. Domain means what you can safely feed this function. Now, I know we can kind of assume that if you wanted to go u sub -1, that would mean that you just subtract 2 degrees from it. I get that, but you can't assume that. You can't know for sure that this ever had any numbers before 72. All we know is that it started at 72. We don't know if the temperature was higher before and they lowered it to 72, or if it's always been 72, or if the temperature never existed until all of a sudden it was 72. So my point is you cannot predict numbers that came before your first term. You can assume them, but you can't know for sure. So at the bottom of each of these, you're going to put this. N has to be greater than or equal to 2. That is called a domain. What that is saying is that this formula only works to predict the second term. I want you to process that for a second. The little sub n, the little sub number, the only thing you can predict with this formula is the second term. That's what this n is greater than or equal to 2 means. The only way this formula works is for the second term, or bigger. You can predict the third term, fourth term, fifth term, but you can't predict the first term. From this formula, you couldn't have predicted we were going to start with 72. If I just said add 2 degrees, you'd be like, well, what do we start with? You can't tell from just the add 2 degrees what the first term should be. Okay, so I know that was a long description, but you're going to have this at the bottom of every one of your formulas. So how do you decide how to make that formula? All right. Almost all your formulas are going to start with a 1. Not all of them, but almost all of them. So if it starts with a 1, then this will always be 1 bigger than that. So if I said u sub 0 was 4. Always is a big word, but I said always. You'll always have that next. Then let's say I add 4 or times, well, let's make it a different number. Let's say 5. We're going to add 5 each time, plus 5. Then what's my domain? N is greater or equal to 1. It'll always be one bigger than whatever you started with. It'll always be one bigger than whatever you started with. 0. All right?
What does that mean?
It means that this formula can only work to tell me u sub 1. It could not tell me u sub 0. This formula can't be used to tell the first number. So this and this, do you get the relationship is always it's one bigger? It'll always be one bigger. And this means this formula only works to tell the second term. In this case, the second term is u sub 1. Okay, so that's why this and this always have to be one bigger than each other. So on that one problem where I had u sub 2024, and I was saying that the school's population here is about 3,400, then at the end of the formula, the domain should have been n has to be greater or equal to, do you remember the rule yet? 2025. Meaning that this will only work to predict year 2025, see? It can't predict, the formula can't predict the first number. We don't know where it's going to start. All right, so that's how the domain thing works. It's just a little statement at the end that says, hey, this only works for the second term or bigger. And in our case, the second term would be one bigger than that. Do you get? You can't predict the population of our school before I tell you anything. Of course, you wouldn't have known that. But once I give you this rule, you can predict that the population, let me just show you, is going to increase by, in this case, what percent? 5%. There's some schools that are growing like that. Especially if it's a developing area, like on the outskirts of the Twin Cities where they've got schools that are like, or areas that are being developed, like farmland is being turned into housing. Those schools have higher growth rates like that because they might not have that many people to start with, but all of a sudden tons of people after a period of time. Okay. Now I think you're ready for the rest of the actual lesson. Here's some words you need to know. Get to page 2. Recursion is a process in which each step is dependent on the step or steps that come before it. That's what we just did. It depends on what happened before it. A sequence is an ordered list of numbers. Term is each of the things that are in it, and we usually call them like u sub 1, u sub 2, etc. A recursive formula, that's these things. That's a recursive formula. And that little part of it started with a D. Who's got a short-term memory? It's called the what? Domain. Very good. That part's called the domain. Remember me saying that it would always be one bigger than whatever you started with? All right. This sequence, I can tell by looking at it. Is it recursive? Oh, sorry, they're all recursive. Is it geometric or arithmetic? Arithmetic, because you're adding. What did this formula start with? A 5. And it also happened to be u sub 1. But look at this one. U sub 0 is our first term. It's kind of like one of those real world problems that starts at 0 before you start your experiment. And then 1 second later, it'd be like u sub 1. Notice I said these would always be there. So far, they've always been there. And then this little thing that starts with a D, what's it called again? Domain. Notice how it's one bigger than that. It's all making sense? All right, the next page then. So if this is my question, 20, 13, 6, negative 1, negative 8, do you see what's going on? It's going down. Down by how much? 7. Can you write the common difference? Well, difference means subtract, and common means it keeps doing it over and over again. What is the common difference then? Negative 7 is technically the right answer. I get that 7 is the difference between those two numbers, but we got to show that it's going down instead of up. So negative 7. What's a recursive formula? Ooh, can you write me a formula for that? Hint, let's all start with u sub 1. I know you could start with u sub 0. You could start with u sub 2024. But when you get a choice, choose 1. It's always easier. So u sub 1. Carter, what's u sub 1?
Would be 20.
Yep. What always comes next, Becca?
un equals un minus 1.
Yep. And then I gotta say what happened each time, which is -7. Now, what's the 11th term? Well, that's a pain in the butt. Is there a way to do this with like a calculator or something? Yes, there is. Now, I know some of you brought your calculators, but many of you didn't. How many of you actually have your graphing calculator with you? Raise your hand if you do. Who does not? I just need to get a feeling for how many we have. And I don't have that many. Okay, so there is a way that would only work for homework, and that is there's a digital version of the graphing calculator, but what I think we should just do is wait till tomorrow. Like, I'm not going to make you in class do stuff with a calculator that you don't have. But I strongly recommend that you take a second and do like this. Set a reminder for tomorrow at 6 a.m. Bring calculator. And poof, I've got an alarm reminding myself to bring a calculator. And I actually need to do that because I need to bring my backup calculators for you guys. So this will be a reminder I actually need. You need to remind yourself. You need a graphing calculator. It's a pain in the butt to use the one that's online. It'll take you like 5 extra minutes to finally get into the thing. And everybody else will just pull it out of their backpack. So have your graphing calculator with you tomorrow. If you don't have one and you can't afford one, I get it. They're expensive. Talk to me about it. If it's a real financial need situation, I have some extra ones. And I get them on eBay for like 35 bucks used. And I'd be happy to share one with you if you have a financial need. Just talk to me. All right. So what's the 11th term? Well, you'd probably want a calculator to do this in real life, but all you'd have to do is keep going. That's the first term, second, third, fourth, fifth, right? And you just keep on subtracting 7 a bunch more times and you'll get it. It's slow, but it works. There's a calculator way that I'll show you tomorrow. All right. So we're not going to do that activity thing. This one is a concert hall. We actually have a test question that's similar to this, so let's talk about it. Draw like this, and imagine that's a whole bunch of seats in a row that are in a concert, like stadium format, and there's 59 in this row. And then in row 2, it's a little bigger because it like curves like this. And so there's more seats in that row. In fact, there's 63. Do you get what's happening here? They started with 59. They went to 63. The next one's 67. Is it going up by a constant thing each time? Yup. How much? 4. So basically, if you cut it back to just the bare facts, it started with this and it's going up by 4 each time. Can you write an equation for that? Sure you can. U sub, if you get to pick, I'd pick U sub 1. If you had to, you could have used U sub 0. What's always next? Excellent. And then what's happening each time? Plus 4. And then, the domain. It's really easy to forget. N has to be greater or equal to 2, because it's 1 bigger than that. There, you learned what you needed to learn today. Now let's find the homework. All the way to the homework part. That's a good question. I heard him. I'm going to say it. Are you going to do your homework this semester? And here's how it will matter. It's up to you. I can't make you do your homework, but your homework does count for 10% of your grade. And if you think, oh, man, that means 90% of it's tests, and so homework doesn't really matter. At the end, the kid that literally doesn't do any homework, it's as simple as this. You take whatever your test grade would be, and you subtract 10% from it. If you didn't do any homework, you're going to lose 10%. That 10% actually matters. You know, like if you don't do any homework, you'll have a 0 in that category. That's how that works. Subtract 10% off your grade. And nobody in here is going to have that high of a grade that they'll still have an A. Even if you had 100%, you take off 10%, then you got a 90, which is an A minus. Okay, so nobody can survive that and get a straight A. You could be a genius and you could get an A minus without doing your homework. It's true. But you'd have to have 100% on every test. And that's hard, very hard. You have to get every problem right on every single test. So all I'm trying to say is do your homework. It's up to you. I can't make you, but it does matter. Some of you can survive missing an assignment occasionally and still get an A, as long as you get A's on every test. All right. So, more realistic scenario is the kid that doesn't do the homework usually gets a B on their tests and then subtract 10%. So then I got a C. And that's a pretty sucky grade. All you had to do is your homework, and you probably would have done better than a B in the first place. So, it's just smart. Do your homework. All right, so let's get to the first problem of the homework. It is a worksheet. I oftentimes cut them down to make them smaller. So, oh wait, it's a Schoology quiz this time. It is a Schoology quiz, my bad. Find the Schoology quiz. Open it to problem 1. All right, let me look at it. Thank you. So it starts with 20. U1. And then UN minus 1 plus 6. And greater than or equal to 2. That's just the domain. You almost never use it. Okay. Is it geometric or arithmetic? What do you say? Arithmetic. So you just put a capital A there. The first 4 terms. Remember, 20 is the first term. Put a comma in there is fine. Don't put any spaces. And then what's the next one got to be? You can do it in your head. 26. What's the next one got to be? 32. And then the first 4 terms, I guess you need one more? 38. You getting the idea? All right. Now, how I do my Schoology quizzes, it is different than some people. You will get the answers after your first try. And so you might be like, awesome, I'll just do a really crappy job the first time and get all the answers and then just put them in on the second try. And the reason that that's a bad idea is you get the average of your 2 scores. So anybody who does it that way and gets like 0 the first time because they just type in crap to see the answers, you're averaging your score with a 0. Okay, so it's not going to, your grade's not going to be great. Even if you get 100% in the second try, you'll average a 50. It's probably not worth it. So basically try. You will get the answers after the first try. And then if you wish, you'll now know all the answers. They won't change the problem. And yeah, you could do it again and get 100%. So typical scenario is a kid gets like an 85% on their first try. And they get 100% if they do it again because they already saw the answers. So for the extra effort of going back through and doing it a second time, you'll get the average of those 2. Which would be a 92.5. You see how that could work?
Do you just write lowercase n minus 1?
That is a good question. How do they want you to type in the subscripts? Usually you can't put just a subscript and act like it's a normal n. That's how you type U sub n when in Schoology. You put a parenthesis around a parenthesis around the n. That's a way of saying subscript. And U parenthesis n minus 1. So when you have to do those subscripts, that's what you would type. Now, if you ever have a situation where it was not clear how to type it, like they didn't give you a hint, and you have the right answer, you just typed it wrong, I can give you points back. Anders. Lowercase, always lowercase for all your letters, including the first one. Like, you never on Schoology need to type capitals. Just use lowercase letters for everything.
Do we put the plus and minus before or after?
I don't know what you're talking about. Plus or minus, before or after. What are you talking
Same
about?
thing that we're talking about right here.
Do you mean like right here?
Yeah.
Oh, so if I was going to say plus 6, I just go like that. No spaces, ever. Don't ever put spaces in Schoology answers. All right, and I totally get that there might be questions about how to type certain things. Like, just walk up and ask me. Now, one of the things that is important is first impressions. Right now, you've all made a good first impression in that you're here. There's a couple kids that aren't, and I'm gonna like try to figure out. Maybe they're just really sick. I don't know. But second first impression is gonna be: are you gonna do your homework? So I don't know some of you, and I'm gonna get that feeling from these first few assignments. If you're gonna start skipping assignments, don't do it on day 1. Just, you know, I gotta get an impression of you, and I don't want that to be a slacker on the first couple days. I get some of you might be geniuses and have way too big of a schedule, and you might miss some homework, and that's okay. But it shouldn't happen on the first day. That's all I got for you for today.